turbine. In getting the calculation of it, we're going to use the Bernoulli's energy theorem or the Bernoulli's principle. So as far as I know, the Bernoulli's principle was assigned before my topic. So I do believe that you have already the knowledge about it if the reporter discussed it with you already. But if not, it's okay because you can totally understand my topic today. So in Bernoulli's principle, we learned from the Bernoulli's principle on how do we apply the kinetic and potential energy. And also we learned in the Bernoulli's principle on how we're going to add if there is an head loss. So going back to our topic, which is a turbine, I'm going to discuss to you on how we're going to apply the Bernoulli's energy equation in turbine. But before that, I'm going to discuss to you first the basic definition of turbine.
Turbine. It provides electric current with energy coming from the fluid.
So in order for us to really understand the work of turbine, we have an illustration here. So let's just imagine that this is a waterfalls. So this is a waterfalls. So we have a kinetic energy here coming from our waterfalls, and we have something to put here, which is the turbine. So our turbine, ilalagay natin siya dito. This is our turbine. So kapag dumalo yung energy coming from our waterfalls, tumama siya or tatama siya dito sa ating turbine. And kapag tatama siya sa ating turbine, that energy or it will convert the energy coming from the waterfalls into the electricity. So let's just put in our turbine the 0.1 here and our 0.2 pagbaba ng waterfalls. So paano yung nangyayari dito sa ating energy balance? So we said that in Bernoulli's energy equation, so in our Bernoulli's energy equation, the energy in point 1 is equals to the energy in point 2. Pero nung dumalo yung tubig dito sa dumalo yung energy at tumawad dito sa ating turbine, it converted that energy into electricity dahil may mga nakuha na energy yung ating turbine. Kumbaga, nahigop niya yung ibang energy coming from our waterfall. So, nabawasan yung ating energy dyan. And our equation will be energy in point 1. Our equation will be energy in point 1 minus the energy head extracted. Ibig sabihin, yung energy na nawala galing sa point 1 is equals to energy in point 2. So knowing that, we can expand our equation. So as we said, we're going to subtract our energy head extracted. So our equation will be this. So our equation, so energy in point 1 or the pressure 1 over the unit weight plus the elevation head in point 1 plus the velocity head in point 1 squared over 2g minus the energy head extracted is equals to our energy in point 2. So pressure 2 over unit weight plus Z2 plus V2 squared over 2J. So this is our equation if we have a turbine. We could also have a head loss. Our head loss can be due to friction na nasa loob ng ating pipes if ito ay magaspang. If we have head loss, we just only need to subtract it from our energy equation. So let us consider if we have head loss. So this will be our equation if we have head loss. So our equation will be energy in point 1, the pressure 1 over unit weight, plus the elevation head in point 1 or the Z1 plus the velocity head in point 1 squared over 2G minus the energy head extracted minus the head loss is equals to our energy in point 2, the pressure 2 over unit weight plus Z2 plus V2 squared over 2G. So this is our equation if we have head loss in turbine. And we can elaborate this if ipapasok na natin yung ating discussion about the power and efficiency. But for now, we need to clarify first or lilinawin natin muna kung ano ba talaga itong turbine at kung ano ang gamit nito. Dahil makikita natin ito sa ating industry, maraming mga tao na gumagamit ng turbine.
A turbine is a device that harnesses the kinetic energy of some fluid such as water, steam, air, or combustion gases and turns this into the rotational motion of the device itself. Turbines are generally used in electrical generation, engines, and propulsion system. So ginagamit natin yung turbine for electrical generation and we produce electricity using turbine. So the source of it is the kinetic energy from some fluids. Just like for our example, the energy coming from the waterfalls and then we are converting that into electricity. Now we have different kinds of turbine. The Francis turbine, fixed pitch propeller, Torgo, Pelton, Kaplan, and cross flow. So we're not going to discuss in detail their differences, but I'm going to show you the basic example so you can visualize how turbine works. Just like for our example earlier, we have a waterfalls. In here, we have energy coming from our fluid. Yung energy na yan, dahil nagfo-flow yung ating fluid pababa, it causes the device to rotate. Just like in our definition, it turns this into rotational motion of the device itself. And from this mechanical motion, here we are generating electricity. To clearly understand if ano ba talaga siya in reality, we have example here. We have a flowing fluid and it's causing the turbine to rotate or the propeller sa turbine. So this is an example of water turbine. We have also the wind turbine, yung mga nakikita nating windmills. In here, the fluid is gas that causes rotation to our propeller of windmills. And also we have the steam turbines. Makikita natin ito sa mga factories and we are using steam from our process and converting that into electricity. Now let's talk about power. So power is different from energy. The unit of power is watts while the unit of energy is joules, which is also Newton meter. In hydraulics, energy is expressed per unit weight. Therefore, our unit is in meters. That's why when we are solving Bernoulli's equation, our unit is meters because we are dividing our energy by weight. If we divide Newton meter by weight, which is in Newton, ang matitira ay meters. Now, let's discuss about the units of power. Watts is equals to 1 joules per second or it also equivalent in 1 Newton meter per second. In 1 horsepower, it is equals to 746 watts or 0.746 kilowatts and also in kilonewton meter per seconds. And also in 1 horsepower, it is equivalent to 550 pounds-feet per seconds. So that will be the units that we are going to use.
If we are solving a problem in hydraulics or in a fluid mechanics, usually we are finding the power. Usually it is not given in the problem. So we need to know the equation of power. So this will be the equation of power. P is equals to Q times gamma times E. The P here is the power, then the Q here, the P is the power and either it is added or extracted. The unit of power is watts, kilowatts, horsepower, kilonewton meter per seconds or Newton meter per seconds. Then the Q here is the discharge of stream or the volumetric flow rate. The unit of Q is cubic meter per seconds or cubic feet per seconds. Then the gamma here is the unit weight. The unit of gamma is kilonewton per cubic meter. Then the E here is the energy consumed or extracted. So this will be our equation in getting the power. Now I'm going to discuss to you about the efficiency. What is efficiency? Maybe you already heard it before because some says that there is no machine that is 100% efficient. Meaning if it was designed with the capacity of this, then the output of it is not always the same. There is always a losses or the 100% is not totally given. So now, let's get the efficiency of our device or our equipment. So the formula of efficiency is this. So, formula in efficiency is equals to P out or the power out divided by the power in times 100. So let's go back to our illustration, the here in waterfalls. So we have a turbine here. We are going to put our P out or our P in here. Our P in is here. Then our P out, this is our P in, this is our P out. And then in our P in, we have 10 kilowatts. And then in our P out, we have 9 kilowatts. So, we can compute this by using our formula in efficiency. So, we'll put our computation here. Efficiency is equals to our P out is 9 kilowatts. And then our P in is 10 kilowatts. We multiply it to 100. So 9 kilowatts divided by 10 kilowatts is equals to 0.9. Then we will multiply it to 100. So the result is 90% efficient. It's 90%. So we're going to cancel this out and we have 90% left. So our turbine has a 90% efficiency. Now, in order for us to apply our discussion, we are going to solve a problem. So our problem is this. Water enters a turbine through a 600 millimeter diameter pipe under a pressure of 14 kilopascals. So we're going to put first our given in our diagram. So we have a diagram here, which is we are using a motor or a device, which is a turbine. So this is our diagram. So it says that in our problem, a water enters a turbine through a 600 millimeter diameter pipe under a pressure of 14 kilopascal. So the fluid na pumapasok sa ating pipe is a water, so H2O. So let's say that dito yung ating point 1. And in our point 1, we have a pressure of our pressure 1 is equals to 14 kilopascal. And our diameter is 600 millimeter. And then it leaves through a 900 millimeter diameter exhaust pipe with a pressure of 4 kilopascal. So here in our exhaust pipe, so we are going to put our pressure, our point 2 here. This is our point 2. So we have a diameter here. Our diameter is equals to 900 millimeter. And then our pressure 2 is 4 kilopascals. Our pressure 2 is equals to 4 kilopascal. A vertical distance of 2.5 separates the centers of the two pipes at the sections where pressures are measured. So here we have an elevation here. So from here up to here. So centers to center. This is our elevation. So we have a 2.5 meter in our elevation. If 500 liters of water pass the motor each second, compute the power supplied to the motor. So our volumetric flow rate is, our Q is equals to 500 liter per second. So we have already our given here. So in the problem, we are going to compute the power supplied to the motor. So we already discussed the equation of power. So the equation of power is P is equals to Q times gamma times E. So I'm going to put our equation in power here in order for us to see it. So this is our equation in power. So we have in our given, we have already the Q and our gamma because gamit natin is tubig. So alam na natin kung ano yung value ng gamma or the unit weight here. So 9.81 yung ating gamma. Then our energy, wala pa tayong nakikita na given sa ating energy. So in order for us to calculate the power, we are going to calculate first the energy. So we are going to use the Bernoulli's energy equation. So in Bernoulli's energy equation, this is our equation that we are going to use in order for us to get the value of E. So this is our equation. So in Bernoulli's, so remember that in Bernoulli's energy equation, energy in point 1 minus energy head extracted is equals to energy in point 2. Now, as you can see in our given, we have already the value in our pressure 1 and our pressure in point 1 and in point 2. We have also our elevation. But at this point, we did not know the value of our velocity. In getting the value in our velocity, we're going to use the equation in volumetric flow rate. So the required of this is only our energy head extracted. In order, we can solve our power later. So we're going to get our value in velocity. Always remember that the value in point 1 of a volumetric flow rate is the same with the value in point 2. So we have a 500 liter per seconds here in our point 1. Therefore, in our point 2, we have also a 500 liter per seconds. Now we are going to get our velocity in point 1. We are going to use the volumetric flow rate equation, which is Q. We're going to write here Q is equals to V times the area. Therefore, our equation will be velocity is equals to Q over area. Now, we are going to get our value in velocity in point 1. So, V1 is equals to our Q is 500 liter per seconds. We are going to convert it because lahat ng ating gagamitin na unit ay nasa cubic meter. So we have 1,000 liter per 1 cubic meter over our pipe. Here is a circular pipe. So we have pi 3.14 times 4. Then divide natin siya in our area which is 600 millimeter. Convert pa rin natin 1,000 millimeter in 1 meter squared. So we are going to calculate this one. 500 divided by 1,000 divided by 3.14 times 4. Then 600 divided by 1,000 is equals to 0.6 or 0.6. So divided by 0.6 squared natin. So ang result ay 1.769. 1.769. Na-try ko siya nang yung gagamitin ko na pag-calculate dito is yung symbol na pi. Ang kinalabasan niya ay 1.768. Pero yung nilagay natin dito is 3.14. So therefore, ating gagamitin ay 1.769. And ating unit ay meter per seconds. Dahil i-cancel natin to. Cancel. Then we have the exponent here, 3 and 2. We are going to subtract that. So we have left. Yung tira na unit is meter per seconds. So, in our velocity in point 2, we're going to get that V2 is equals to our Q ay 500 liter pa rin seconds. Convert pa rin natin. We have 1,000 liter per 1 cubic meter over pi 3.14 times 4 divided by, ang ating area dito is 900 millimeter. So, convert 1,000 millimeter 1 meter squared. So, calculate natin siya. 500 divided by 1,000 divided by 3.14 times 4. 900 divided by 1,000 is equals to 0.9. So, divide natin. Divided by 0.9 squared. Square natin. So, the result is 0.786. So, 0.786. 0.786 meter per second. So, this is our velocity in point 2. Now, we are going to substitute our given in our equation here in order for us to get the energy head extracted. And after we get that, we can solve now our power. As we can see, we have our value in velocity in point 1 and our velocity in point 2. And also, we have the value in pressure in point 1 and pressure 2, or the point 2, we have the value of point 2 in our pressure, and also in our elevation, we have already that value. So now we can substitute it in our equation. So let's substitute it now. Our pressure 1 here, our pressure 1 is equals to 14 kilopascal. We're going to convert it. So, 1 kilopascal and 1 kilonewton per meter squared over our unit weight, which is 9.81. Our unit is kilonewton per cubic meter. And then we are going to add our elevation. Our Z1 is equals to 2.5. 2.5 meter plus our velocity in point 1, 1.769 meter per second squared over our acceleration due to gravity, which is 2 times the 9.81 meter per second squared. And then minus HE is equals to our energy in point 2. But first, we're going to solve this first, our energy in point 1. So, 14 kilopascal divided by 9.81 plus 2.5 plus the velocity in point 1, 1.769 squared divided by 2 times 9.81. So this is our energy in point 1. So now let's continue in our energy in point 2, and our pressure 2 is 4 kilopascal. Convert natin 1 kilopascal in 1 kilonewton per meter squared over the 9.81 kilonewton per cubic meter plus, so here we are going to put a datum line here in our diagram. So we have a datum line here. Our elevation in point 2 is 0. So plus 0. So I'm going to put it here, the continuation. So our velocity 2 is equals to 0 plus 0.786 meter per second squared over 2 times 9.81 meter per second squared. So we are going to solve that now. So 4 kilopascal divided by 9.81 plus 0 plus 0.786 squared divided by 2 times 9.81 is 0.4392. So so here minus HE is equals to 0.4392 meter. So now we're going to subtract it. HE is equals to 4.087 meter minus 0.4392 meter is equals to our HE is equals to 4.087 minus 0.4392 is equals to 3.65. So 3.65. Our HE is 3.65 meter. This is our HE. So this is our HE now. And now we can already solve our power. Now we are going to solve our power. Our equation will be power is equals to Q times weight, unit weight times E. So P is equals to our Q is 500 liter per seconds. And then we're going to convert it. So we have 1,000 liter per 1 cubic meter times our gamma or unit weight is 9.81 kilonewton per cubic meter. And then times to our energy head extracted, which is this 3.65 meter. So we have a result of 17.90 kilowatts. This is our unit because our unit in power is watts, kilowatts, horsepower, kilonewton meter per seconds, or newton meter per seconds. But we can also present this kilowatts into horsepower. So power is equals to 17.9 kilowatts. Then we have 0.746 kilowatts here. This is kilowatts and 1 horsepower. We're going to solve that. 17.9 divided by 0.746 equals 23.99 or it should be 24. So we have 23.99 horsepower or 24 horsepower. So this is our answer if we are going to present this in horsepower. Let me add a question here. Let's say that the energy converted into electricity is only 19 horsepower. What is the efficiency of our motor? So in getting that, we are going to use the formula in efficiency. Efficiency is equals to P out over P in times 100. Example, this is our motor. This is our turbine. And then the P in here is 24 horsepower. And then the P out is 19 horsepower only. So, hindi lahat ng 24 horsepower ay na-convert into electricity. We are going to solve this now. Efficiency, is equals to our P out is 19 horsepower over the P in, which is 24 horsepower, times 100 is equals to 19 divided by 24 times 100 is equals to 79.167. So 79.167%. So this will be our efficiency in our motor. We have 79.167% efficiency. Now we already get the power supply to our motor because the requirement in the problem is only the power. First, we solve the velocity in our point 1 and point 2, and then we have already the given in our pressure 1 and pressure 2, and in order to get the requirement in our problem, which is solving the power, we first solve the energy in order to solve this. So we got this 3.65 meter, and then we substitute here in our equation in power. We got this answer, which is 24 horsepower. And we try to answer the efficiency of our motor. Example, a 19 horsepower. If we have 19 horsepower in P out, then we have 24 horsepower in P in. Then we're going to multiply it in 100. So we got 79.167%. This is our efficiency in motor. And that would be all in my topic. I do hope that you gain knowledge and you understand my topic. So thank you for listening.